The heat exchanger network that we drew yesterday actually had some problems into it. The delta T minimum required at the inlet and the outlet of each heat exchanger should be at least 10 degrees Celsius. The network that we drew yesterday did not satisfy this criteria, क्योंकि यहाँ पर जो टेम्परेचर था 196.7 था एंड यहाँ पर टेम्परेचर आउटलेट 205 था, तो द डिफरेंस बिटवीन द टेम्परेचर इज नॉट 10 डिग्री सेल्सियस, इट इज़ लेस देन दैट. And in case of the exchanger number 5 that we had drawn yesterday, there the outlet temperature here was 106.6, whereas the outlet temperature here was 107.5. So in this case also the delta T minimum criterion is not satisfied. So this heat exchanger network that we had drawn yesterday was actually a bit wrong. So we are now going to rectify the mistakes that we made earlier. So this is the exchanger sheet that we had to draw. I have already drawn here the streams, the hot streams and the cold streams, and written for all the streams the MCP values as well as the enthalpy values that we calculated. Now we had calculated that the cooling water requirement was 10 megawatt. So the first connection that we actually make is the cooling water heat exchanger and the heater exchanger. The cooling water heat exchanger was of 10 megawatt. In this case, the delta T of the hot stream across the right hand side of the pinch here is 150 minus 40, that is 110 degrees Celsius, whereas here the delta T is lesser than that. So at a place where the delta T is more, we put there the cooling water heat exchanger of 10 megawatt. This is the first step that we do. So this is the cooling water heat exchanger that we provide, that has a capacity of 10 megawatt. Similarly, on this side of the pinch, the delta T here was 180 minus 140, that is 40 degrees Celsius, where the delta T here was more than that. So the cooling water so the heater that we had to provide will actually be on this cold stream. So we apply the heater at the end of the cold stream. The capacity was 7.5 megawatt. Now for this stream the MCP value was 0.15 and we had provided a heat exchanger of 10 megawatt. So 10 megawatt divided by 0.15, that is the delta T that we get, and the delta T that we get here, accordingly we make the inlet temperature assumption here, that is 106.7 degrees Celsius. So the inlet to this heat exchanger is 106.7 degrees Celsius. Now out of the 16.5 megawatt requirement, we have provided 10 megawatt requirement. So here the remaining is only 6.5 megawatt. Now we come to the left hand side of the pinch. Here in this stream we have provided 7.5 megawatt of heat. The requirement of this stream was 27 megawatt. So 27 minus 7.5, that is 19.5. So 19.5 was the requirement, is now the new requirement of this cold stream. Now the first heat exchanger that we provide is between the stream number 2 and stream number 4. Because the capacity of stream number 2, the enthalpy, was lesser than the capacity of 19.5. Therefore we provide a heat exchanger which has a capacity of 12.5 megawatt. This is our exchanger number 1. So this stream gets completely satisfied. It required an energy of 12.5 and we have given it the energy 12.5, whereas this stream is not totally satisfied. This stream required an energy of 19.5 and we have provided it with 12.5. So 7 megawatt is the deficit here in this stream. Now the second connection that we make, the second heat exchanger that we provide, is between stream number 4 and stream number 1. So we provide the heat exchanger. This is our exchanger number 2. the capacity of this exchanger is going to be the lesser capacity, that is the 7 megawatt heat exchanger. Now, after providing a heater of 7.5 megawatt, the temperature that we obtain here, 7.5 divided by 0.3, the temperature accordingly we obtain here is 205 degrees. Now, this steam is fulfilled. We provided here a 7 megawatt heat exchanger, so no heat is now available here. In this, we have an excess of 8 megawatt remaining. Here, the exchanger that we provided, so we calculate the delta T here. To calculate the delta T, it is 7 megawatt divided by 0.15 for this. So the temperature that we obtain at the outlet of this is 203.3. Ultimately, now we can only make heat exchange between the stream number 3 and stream number 1. So the final heat exchanger that we provide is the 8 megawatt heat exchanger, since both the streams have the enthalpy of 8 megawatt. So here, after providing 8 megawatt, this stream is satisfied and this stream is also satisfied. It goes up to 150 degrees Celsius. Now we come to the right hand side of the pinch. Here, the first heater that we provide is between stream number 3 and stream number 1. The capacity here was 6.5 and here it was 25. So the heat exchanger would be of 6.5 megawatt. Now this stream gets fulfilled. Here 24 minus 6.5. This is the deficit in this stream, that is 17.5. So now the heat exchange is possible only between stream number 2 and stream number 3. So we provide the final heat exchanger. Since the values of these enthalpies match, we provide a heat exchanger of 17.5 megawatt. In this case, the outlet temperature coming out from the fourth heat exchanger would be the exchanger value 6.5 divided by the 0.2. So accordingly, we get the temperature here is 52.5 degrees Celsius. So now, as we can see, the delta T criterion in this heat exchanger network is satisfied at each and every place. Here the delta T is 203, 180. Here it is 150 and 140. So it is 10 degrees Celsius, the minimum value. Hence, for all heat exchangers, the delta T value of 10 degrees Celsius is satisfied. Hence, this heat exchanger network is correct. Thank you.